probably the image that comes to mind. Think about the built infrastructure, the concrete, the lights, the buildings, the roads, the rail. This is a nice image, but when we really look at cities, especially from a technological perspective, my departure point is a little different. When I think about cities, I think about people. It's about using people and individual people coming together to live in a community. And those built infrastructure aspects are really things that are just in service to all of us in a highly dense environment. Urbanization, since 2008, more people live in cities than in rural areas. This trend is continuing and the population growth isn't helping. New York in the next 20 years will add 3 million people. For those of you who take the train or have tried to look for a parking spot, you've figured out that our infrastructure is at capacity. What was built a long time ago, our subway from 1904, was just not made to deal with the kind of population growth and the urban density that we're experiencing right now. I think people also, they offer a pointer to the truth about how we can look at things, because if cities are about people, then people can be a basis for modeling our perspective about cities and modeling the technology that we apply to help solve our problems. One of the other phenomenon is that when I look at people, I think about one instantiation of a person, and I think about how does that scale out. In New York, it scales out to 9 million, biggest in the US. There are cities that have tens of millions, cities in China approaching 40 million. This is something we've never seen before. And when we talk about scale, scale inherently gives birth to complexity. And complexity gives birth to uncertainty. As we look at the technologies that are dominating the different asset classes, whether it be building technology or energy technology or transportation technology, we see more and more that it's becoming much harder, it's becoming much more complex, there's a lot of risk involved, and from a business perspective, those are all concerns that we try to deal with. Myself, as a geek, if you will, I consider our task as technologists and as designers to have an intelligent design going forward and to try to craft certainty from the complexity and the uncertainty that's facing us. When I look at how to design future transportation systems, I try to use the model that you see here. The model indicates essentially two things. The first thing that it does is I try to use the concept of biomimicry. If a city is a collection of people scaled out, then it should be also true that we can use a single person as a representation of what the major aspects of a city are. The other aspect from a biological perspective is we're also social creatures. And from a social perspective, what we're observing is this huge shift from an industrialized view, or mechanistic view of how things are structured, very hierarchical, very compartmentalized, very siloed, and very centralized, into the social shift that we see now where things are highly distributed, highly interdependent, and highly connected. And those shifts are important because those shifts also dominate the organizations that really contribute to the owners of the assets, the private sectors that are trying to improve these things, and society's changing. So we need an interconnected model, one based, I believe, on a biological perspective. And when we talk about biology, I just look at myself. I think human beings are a system of systems, as cities are. And from an architectural perspective, when I decompose the aspects of who I am, I find four major areas at a high-level architecture that are highly interconnected. And I want to talk a little bit about that here. First, I have my physical structure. That's my body. All cities have a physical structure, whether it be their, if you talk about their energy system, the buildings, and their waterways, and their rail, road, or transportation infrastructure, that is essentially the body of a city. Cities also live within an environment. Our relationship to our environment is extremely important. One thing that we see in cities, and this has been talked about a lot, is that as populations grow or as they double, their efficiency changes. As biological creatures, our efficiency is essentially reducing, or our efficiency increases as animals get bigger. As cities get bigger, our efficiency decreases. We start to consume more resources. And if you look into the research regarding biocapacity and our ecological footprint, we're consuming a lot more than the Earth can give us. We also contribute, or can contribute positively to the environment. So it's not a one-way street, but it's, my body exists in something, and I need to take care for that when I think about how to implement different technologies. The other thing I have is I have my belief systems. We all do. We all look at the world in our own way. And cities collectively also embody their belief systems, how they look at what's important for them, what their values are. Those are typically embodied in the government, you know, our economics. Economics is essentially, from my understanding, the study of why people do what they do. Our subculture. So we have all of these thoughts and ideas that also govern our actions, and they also play an equally important role, not only in innovation, but in the technological decisions that we make. And my body has qualities. So not functions or structure that I have, but properties, what we call non-functional requirements in the architectural world. There's my health, my safety and security, my education, and those are also extremely important components. It's impossible to look at technology without taking all these aspects into consideration. And so when we talk about specifically transportation, or we talk about the built infrastructure, one trend from my perspective is we've spent a lot of time building kind of the muscular and skeletal infrastructure of our built infrastructure. And what we see now is really putting in our nervous system. Our infrastructure assets are starting to think. And when we talk about smart, specifically as it relates to infrastructure, I use a different technological model to show you how I see the entire value chain and what a potential trajectory is regarding technologies in the future. This is something I call the built infrastructure maturity model. We're building tunnels right now. When we built tunnels, 50 or 100 years ago, the only important player were the sandhogs and the diggers. Now when we build tunnels, we're building intelligent tunnels. Telematics, all this information technology is equally important and equally a part of every new infrastructure build out. And it follows a natural trajectory. So typically you start with telematics, so very basic systems that can tell you if something's on or off. Once you advance from that, you go to PLCs and RTUs, so essentially computers that can control series of electromechanical devices to provide even more intelligence. You have SCADA systems. SCADA systems are unbelievably important. This kind of technology is what's really dominating our built infrastructure. Just to give you a practical example, for those of you who ride the subway, we have the countdown clocks. That's run by a SCADA system. The same SCADA system and the same software is running the Large Hadron Collider for CERN and helping collect data on subatomic particles colliding. This technology is controlling almost every aspect of your life. If Facebook reaches 800 million people, I would feel safe saying SCADA is touching 5 billion. And there's a lot of innovation going on in that space as well. The problem is that as we scale this technology out and we're controlling thousands and thousands and thousands and millions of elements, it's producing more data than we know what to do with. We just don't have the cognitive bandwidth to understand all the things that our systems are doing. And that's why I think now you really see the emergence of big data, which is essentially the ability to understand all of the exhaust data that all of the systems that we created are actually producing. And it makes it in a way that's tangible so that we can make decisions. From there, we look at optimization. Once you have all this information, we start to optimize different asset classes. It's a technology that has been around for a while, but is really emerging now.